Sometimes one of the hardest things about math is not necessarily doing each procedure or each process, but it's more recognizing when to use each method. And so today's lesson is all about choosing a method of when should I use this to solve. And so we're just going to go through each method and we're going to just get really comfortable with recognizing, and that's our purpose for today. Let's see. So when should I use, which method should I use? And we're going to fill out this table. Here's the fun fact. Quadratic formula. Let's start there. You can use quadratic formula anytime you want. Or when no other method works. This thing about quadratic formula, it's for any quadratic equation. So as long as you have a quadratic, you can use it. But it's not always the fastest, and it's not always the simplest to use. And so as far as when we use everything else with factoring, hopefully you guys are pretty comfortable with factoring by now. I would say you should factor when the equation factors. Meaning that I can find two numbers that multiply to the a times c and add to the middle term b. We can complete the square when a equals 1 and b is even. And remember, this is coming from standard form. Ax squared plus bx plus c. So if there's no coefficient in front of my x squared, that means there's an invisible 1. So that's when a equals 1, and we want our middle coefficient to be even. As far as taking a square root, we want to use a square root when there's just an x squared or an x in parentheses being squared. We'll just leave it at that. Okay, so we're going to use this now to kind of go through these. And we're going to pick a method and say why we'd use that method. And there's not necessarily just one right answer. And so, in reality, we could use quadratic formula for every single one of these, but I don't want you to use quadratic formula for every single one of these. So let's look at this first one. I personally always check factoring first because factoring is the fastest method if it can actually factor. So I can say, okay, is there anything that multiplies to 6 but adds to negative 10? No, there is not. Okay, so it does not factor, so I know that. Taking a square root, there's an x squared here, but there's also this minus 10x. And so because I have a linear term there, meaning it has a little, a just x on it, then that means I can't solve just by taking a square root right now. Well, let's check complete the square. When a equals 1, all right, a equals 1 here. My b term, negative 10, is even. So I'm going to choose complete the square. When I say why, here's my personal reasons why. It doesn't factor. And a equals 1 and b is even. And so that's my method. So now let's go through and solve that. I'm going to start by subtracting 6. X squared minus 10x. Let's leave a blank on both sides. So now I have to create a perfect square trinomial, and the way that we're going to do that, we need to find the value that completes the square, meaning the value that creates the perfect square trinomial. We do that by taking our middle term b, dividing it by 2, And now we're going to square that. So I'm going to add 25 in this blank on both sides because I can't just add it to one side. And now that I have a perfect square trinomial, we can rewrite it as a squared binomial. And this would become x minus 5. And you can double check if you distribute x minus 5 times another x minus 5, you get the x squared minus 10x plus 25, and that equals 19. Now we can take a square root. X minus 5 equals plus or minus square root 19. And now we can just add 5 to both sides. Ta-da! Okay. Part B. Once again, we're going to check with our methods here. I always check for factoring first. So the first thing I look for when I factor is a greatest common factor. I see that I have it, everything is divisible by 2, so I'm just going to factor out the 2. X squared minus 9x plus 14 equals 0. So when I go to factor this, I'm looking for two numbers that multiply to 14 but add to negative 9. That'd be a negative 2 and a negative 7. And because I don't have a coefficient in front of my squared term anymore, because I factored it out, this means I can just use the shortcut to factor, which means I get x minus 2 and then x minus 7 equals 0. And now that I have a bunch of stuff being multiplied together to be 0, we can use the zero product property to say that I know one of these things has to be 0. Remember, 2 can't be 0 because that's not a thing, but x minus 2 can be 0 or x minus 7 can be 0. So then we just solve for x from there. I get x equals 2, and I get x equals 7. So, the method I chose here was factoring. Why? Because the equation factors. Okay. Part C. Okay, I'm going to check to see if it factors. Does anything multiply to 12 but add to negative 5? Well, factors of 12 are 1 and 12, 2 and 6, 3 and 4. And looks like none of those are going to make a difference of 5, so this does not factor, so we're not going to choose factoring. I have a negative 5x here, so we're not going to use square root because I have like just an x in there. And then a equals 1, but b is odd, which means I'm not going to complete the square, so I'm going to use quadratic formula. No other method fits the situation. I didn't say no other method works because, I mean, you could complete the square on it, but then we'd have to deal with fractions, and nobody wants to deal with that, so we're just going to go with quadratic formula. So, we're going to, first let's write our quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So a equals 1, b equals negative 5, and c equals 12. And now we just plug in. X equals, if negative, well, b is negative 5, so negative b is going to be a positive 5. Because remember, that could also mean opposite. Negative b squared minus 4 times a times c all over 2a. See, it's 25 minus 48. over 2. Okay, let's pull out a calculator. 25 minus 48 is negative 23. 23 doesn't have any factors, but I see that there's the negative there. And so I'm just going to rip the i's out so nicely. Okay. And part D, I'm just going to show we're going to do a square root method because look, we have this being squared. The only x that's there is being squared in some capacity. So we're going to work backwards through order of operations. So I'm going to start by adding the 18. And now we're going to divide by 3. And now we're going to take the square root. So x plus 4 equals plus or minus square root 6, because square root 6 doesn't simplify any further. And now we just subtract 4. X equals negative 4 plus or minus square root 6.